This is Steve Notley with the field engineering team here at Wallaroo AI. And today we're going to be looking at an example on how we can deploy computer vision models for retail use cases using the Wallaroo platform. What we can see here is the Wallaroo Operations Center. This is a dashboard that I can use to upload, deploy, manage, and monitor models that I have in production using Wallaroo. Before we jump into this specific example, let's take a look at some of the components of Wallaroo and how they relate to one another. The first concept we're going to talk about in Wallaroo is the concept of workspaces. You can think of workspaces as a place to organize the work that your team does within the Wallaroo platform. Some organizations choose to have one workspace per initiative, per team. That's really up to you. Inside of a workspace, we can upload models. Now, these can be both things that you typically think of when you think of a model, like an XGBoost or a scikit-learn TensorFlow model. It can also be arbitrary pieces of Python code that you want to treat as a model. In Wallaroo, you combine these models into what we call pipelines. These are the units that you actually go and deploy, and they consist of one or more model steps. So you can either have, as we see to the right, just one model that stands alone and is deployed in a pipeline, or as we see to the left, multiple models where the output of one feeds into the input of the next. The last piece is the administration layer, and this is where you can add users to your workspace and control who has permissions to change what. Now let's see how we can use the Wallaroo SDK to upload and deploy one of these models. Now I can click on the Launch JupyterHub button here to launch the JupyterHub instance that comes pre-installed with the Wallaroo cluster. Now for this example, we will be using this built-in JupyterHub instance, but it's worth mentioning that all of this is going to be done using the Wallaroo SDK. This can be pip installed like any other Python library, and from there you can use your favorite IDE or other cloud platform to upload and deploy these models. Now the model we're going to be using for this example today revolves around the idea of using computer vision for inventory management in retail. This means that we have cameras set up to monitor shelves, identify objects, and count them so that we know the status of our inventory. And so for this example, we'll be deploying a model that takes in these images and identifies the objects in them and classifies them correctly. We'll also be making a visualization like this so that we can actually interpret the output from our model and test to make sure it's working correctly. First, we'll import all the libraries we need, including the Wallaroo SDK that we mentioned earlier. Next, we can actually authenticate to our cluster and select the workspace that we're going to be working in. I can do that by creating a Wallaroo client instance and then setting my current workspace. Next, we're ready to actually deploy our model. And in Wallaroo, that comes down to really these three blocks of code. The first of these three lines deals with uploading our model to the Wallaroo cluster. So here we'll be using a MobileNet model, and we have that saved in an Onyx format, and we'll be uploading that to our Wallaroo cluster. We do this with the upload model function, which takes as input the saved model file itself, as well as the framework that we use. So you can see we tell it to expect an Onyx file, but this can just as easily be any of your favorite frameworks. We support things like TensorFlow, PyTorch, scikit-learn, XGBoost, and others. Next, we specify the configuration for our deployment. We do that by creating the deployment config builder here, specifying how many CPUs and how much memory we want the model to have, how many concurrent instances we want to spin up of this model. For this case, we'll just be using one, but in the event that we want to be able to handle multiple incoming requests simultaneously, we could easily specify more. And then I go ahead and build that config to be used. Now, it's not shown here, but in this same step, I can also specify things like GPUs, if I want to use GPUs at inference time, as well as alternative architectures to the standard x86, such as ARM. Finally, I can use these components to create our pipeline and deploy to production. So in this last chunk here, we go ahead and build our pipeline. We add our model object as our one, and in this case, our only model step. And then we go ahead and call the .deploy function to initiate deployment, and that uses the deployment config that we specified earlier. Following this, in 45 seconds or less, I will have my model up and running in production, ready to receive inferences. Now that I have my model in production, I can go ahead and actually test out our model to make sure it's returning inference results as expected. Let's go ahead and take a look at a sample image that we can run inference on in order to test out our pipeline. So we'll see the same image that we saw at the top of this example of this shelf, which has many objects on it for us to classify. We can then go ahead and reshape this image to the specs that we need and actually run our inferences using the .infer function. This will take this image as a data frame and return our inference results. Once our inference call completes, I can examine the results and see that in the returned data frame, I have both my input tensor containing our image input, as well as our three outputs from our model, which are the bounding boxes that were identified, the classifications made on each of those boxes, and then the confidences that is ascribed to each of those classifications. Now I can use some plotting code to overlay these results on top of our original image and examine how our model did. Now I can see the results from my model and see the objects that it has detected and classified. And if I'm happy with these results, I can go ahead and begin to integrate my model in my other production systems. In order to do that integration with the other systems that I have, I can go ahead and access the URL for this pipeline. This will give me the external facing URL that I can use to send those requests for inference. So at this point, I have my computer vision model fully deployed in production and ready to receive inferences, as well as this external URL that I can use to integrate into other systems. Now that I have this model in production, I can focus on all of the things that come after that step. At Wallaroo, we aim to help you get these models into production as quickly and easily as possible, as we saw today by deploying that model in only 3 lines of code. But we also want to help you focus on everything that comes after. This includes integrating your deployment workflow into other services, monitoring for drift both in your models as well as in your datasets. This is done by Wallaroo's flexible assays interface, where you can automatically detect and alert on drift for any input or output to your pipelines. Wallaroo also supports more advanced deployment patterns geared towards model testing. This includes things like A/B testing and shadow deployments so that you can compare your challenger models to your champion models that you have in production. Wallaroo also supports no downtime hot swapping so that you can promote these models as necessary. Finally, Wallaroo allows you to automate batch workflows so that you can automatically schedule pipelines to run on a regular basis, including pulling fresh data from external data sources and writing those results back. And so today we've seen how we can go from saved model to deployed production pipeline using Wallaroo so that we can start to think about all of these more advanced features and the other ways that Wallaroo can help ensure the health of my deployment lifecycle.